Python is a multi-purpose programming language commonly used among data professionals, data analysts, and data scientists. So companies all over the world use Python to harvest insights from their data sets and gain a competitive advantage against their competitors. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 18. We'll be learning and solving our first project so far in this whole learning journey, which is the 100 days learning journey of Python. We started from day one and we've covered introduction to Python and some intermediate Python knowledge. So in the introduction to Python, we did basics of Python, we did Python list, functions and packages, and we got introduced to our first package, which is the NumPy package. Then when it comes to the intermediate Python, we looked at matplotlib. We also learned all about dictionaries and pandas. We learned all about logic, control flow, and filtering. We also learned about loops in Python, and we did a case study, which is the ACA statistics case study, which was the last thing we did on the channel. So on today's live stream, we'll be looking at we'll be applying all what we've learned both in introduction to Python and intermediate Python to what? To solve a movie, to manipulate and visualize a movie data, which is the Netflix of movie. We'll be doing investigation all about on the Netflix movie data set. I'll leave a link to the data set, the CSV file under the description. So we'll be using all of we've learned in introduction to Python and intermediate Python to solve and perform EDA on this Netflix movie Python. All right, so that's all we have to do for this live stream, and hopefully we are going to complete it on this particular live stream actually. So without further ado, let's jump back to learning. Also, do well to subscribe to the channel and give this video a thumbs up so you can always catch me and put on the notification bell so you can also be the first to know whenever I go live or drop a new content on the channel. So without any other delay, let's jump back to this case studies investigating a Netflix movies with Python. So actually, we're on the DataCamp platform, and we've actually subscribed to a 1 year subscription on the platform. So I'm trying to make use of the whole subscription and get myself upskill myself in data analytics too for this year 2024. So this is the goal for the whole of this year. So I go under the career tag section without wasting any more time. I just go to the career tag section here. Just a second there. Very quick. So we are on the data analyst in Python career track, and we're actually 22% in the whole career track. And we actually started this fun way of learning. It all started with data analyst in SQL. Then we moved to data analyst in Power BI. And right now we're on data analyst in Python. So you can catch all the whole SQL and Power BI learning journey on the live stream tab on the channel. So you can also upskill yourself in those analytics too. So I click on the data analysis in Python real quick. You can see what we've covered so far. We've done introduction to Python. We've done intermediate Python also. So this was where we learned all about Python basics. In the intermediate section, we covered a couple of matplotlib dictionaries and pandas, logic, control flow and filtering, loops, and we did our first case study. So this is our first Python project, which is this Netflix data analysis. If I click on it, so we're going to apply the foundational Python skills you've learned in introduction to Python and intermediate Python by manipulating and visualizing movie data. So we have to explore Netflix movie data and perform exploratory data analysis for a production company to uncover insights about movies from a particular decade. So this is what we want to do in this particular live stream. So I'll just start the project real quick. Before that, I always love to use the DataCamp platform and also make use of my own Jupyter notebook, my own Python environment on my laptop. So I'll just go ahead. I've installed Anaconda Navigator on my laptop. So if you want to know how to install Anaconda Navigator, I'll encourage you to go and watch the first video in this series, which is day 1 of this series. where we actually install this Anaconda Navigator. So I'll just launch my Jupyter notebook real quick. So it's going to launch this on my web browser. And also I have the Netflix or CSV data sets for this challenge already downloaded. So I'll drop a link. I'll link it under the YouTube description so you can also download the file, and get your hands dirty also. While this is coming up, I don't know why it is taking time. So let's just read. Okay, it's up. So while that is coming up, I'll just go ahead and start reading all about this. So we have to follow this guided, it is a guided project actually. So we have a couple of instructions to follow and solve the challenge. So the first instruction says perform exploratory data analysis on the Netflix data.csv data to understand more about movies from the 90s. That's probably from the 1990 to the 90 to 1999. So that is from the 90s. So we have to answer this couple of questions. These are resources we could use. All we've covered so far. This is the guide and there's a solution here. But before we jump into the solution, let's try to solve it ourselves and see if we can actually provide the code to the answer. So this is the dicta dictionary. So it says Netflix, what started in 1997 as a DVD rental service and since exploded into one of the largest entertainment and media companies. Given the large number of movies and series available on the platform, it is a perfect opportunity to flex your exploratory data analysis skills and dive into the entertainment industry. So you work for a production company that specializes in nostalgic styles. So you want to do some research on movies released in the 90s, in the 1990s. You will delve into the Netflix data and perform exploratory data analysis to better understand this awesome movie decade. So you have been supplied with the data sets. We have the data set downloaded already with the following table detailing the column names and description. So feel free to experiment further after submitting. So we have the dictionary here. So the show ID, probably it is a unique ID for each show. So the ID of the show, the type of show. Okay, let me launch the data set right here. I have data sets, the CSV data file here. We have it here. We just scroll up. You can see the show ID here. Let me just see if we could add a couple of filter to the data set. Yeah, we could do that. Do that. The show ID is definitely unique record. So let's go back here. We have the type of show. So how many type of show do we have here? It's either it is a movie or it is a TV show. So we know that information right there. It's either it is a movie or a TV show. Also, what do we have here? We have title of the show. You can see we have the title right here. Title of the show. You can see some of them are just numbers. It can be probably July, August, 7, 323, 59, and so on. We have the title of the shows. We have the director of the movie or the probably the director of the movie or the TV show, either of the two. We have the cast of the show, country, or date added to Netflix, the release year of the. So we want to work with the release year, the movie. So I think the two most important column we will be working with in this data set is the type of show, which is movie, and the release year, movie that are released in the year in the 90s. So definitely, so after the release year, and probably some other columns, but the most specific columns we'll be looking at is the first two columns, as we can see on the question. We have the release year, definitely important. We have the description of the movie. We have the genre of the movie. Probably it is action movie, it is anime series, British TV series, comedies, crime TV, and so on. So interesting. So let's get started. So the first instruction says, what was the most frequent movie duration in the 90s? Save an experiment, save an approximate answer as an integer, called duration. The first thing we need to do, let's even see what the Netflix movie dataset looks like in Python rather than looking at it as a CSV file in Excel. So we've seen what it actually looks like in this in the Excel environment. Let's connect to this data in Python in Jupyter Notebook and see how it actually looks like. So before we just continue, I'll just create my new. Let me just go to my download section here. Go to my DataCamp resources real quick. Python for data analysis or investigating data set section. I have it here as a CSV file. So I'll just create a new Jupyter Notebook pathway in this section here. I'll just create a new. You can just go ahead and create a new notebook as well. So I'm going to be using Python 3. I'm just going to rename it as investigating Netflix movies. I'll just rename that like that. Boom, we are good to go. Just give me like a couple of seconds here. Yep, I'm back. So we have our Python environment prepared already. So if I compare it to this environment, I just have this a couple of markdown here, but I could just make use of it anyway. So the first thing we need to start is, let's start the first line of code here and say what we need to do first is just connect to the data set, but we need to import a couple of libraries. Let's import pandas. Import. I'll just make it as a comment. So this is going to be a comment. I'm going to use the comment sign to do this. Yeah, so we have it there. So I want to import importing pandas. Let's import pandas and math plot. We'll be using pandas to connect to the CSV dataset as a data frame. We'll be using matplotlib to visualize our dataset. So that's probably most of people. We can use NumPy also. It depends. Matplotlib. Okay. What is wrong with this line of code here? Okay, it is actually trying to save. Okay, so I'm going to say imports pandas as PD. Next for the imports. So I want to import matplotlib.plyplot with matplotlib dot py. Have a matplotlib.plyplot there. As what's wrong with the Python environment here? As PLT. So I'm going to do the same time. I'm just going to copy this line of code here just to make it faster. So if I run this bunch of code, let's run it first and see. If you don't run into any error, that means that is correct. Voila, so that is correct. I'm just going to do the same thing in my own environment, importing pandas, spell that wrongly, pandas and matplotlib. Let's run that. If I run this bunch of code, it's important. So the next thing we need to do is now connect to the data set. So I'm going to write a bunch of code here. So I want to read the let's see, reading the Netflix CSV as a data frame. So we need to connect to it as a data frame. So to do that, we're going to use pandas to connect to the CSV file. So you can just say Netflix underscore data frame or Netflix data frame equals to, let's make it a smaller version, as a pd dot read, then underscore CSV. So this is the function here. Then we open a bracket, saving field. So it's trying to save, but it is running into an error. What's the challenge? The DataCamp platform right now. Okay, saving again. So we have to make sure we are connecting to the right spelling, which is this Netflix.dataset. Let me just copy it from here. Aha. So we want to read the data set. I'll just run it. Let's see. If it runs successfully, that means it saw it. So let me just do the same thing from my Jupyter notebook here. But the only thing I have to make sure it is spelled correctly. I see Netflix underscore data.csv. So I make sure I save this Netflix underscore data.csv. I save it the same way. If I run the code, I shouldn't get any error. Great. So now let's see the first 5 rows of the data set. Rather than looking at it in an Excel file like this, I want to see it the way it's supposed to be seen in the Python environment. So to do that, I'll just say, come back here and add one more line of code here and say, so I'll just call on the Netflix data set. So it's going to be Netflix. So it's as see my data frame there, dot add, open and close the bracket. If you should run this code now, voila, you can see. So we're actually seeing S2, S3, S4, S5, X6. Just the way it is here. S2, S3, S4, X5, X6. Just the way it is in Excel, but much more better in the Python environment. So I'll just copy this line of code and run it here also. So I'll just comment it. Oh, you can see I want to comment something here. What I should be able to comment do. Okay. I want to add a comment there. So I want to say show the first 5 rows of data. So if I'm sharing this workbook with someone, so the person should understand what each line of code is doing. So same thing, you can see we're now looking at it in the Python environment better now. So I'm going to leave same comments here. Now we've done the most basic stuff. So let's go to the most important stuff by answering the data set. I'll just go to we have 3 questions to answer here. It says filter the data for movies released in the 1990s. Find the most frequent movie duration. Count the number of short action movies from the 1990s. So the goal here, we want to work with only movies released in the year. You can see released in the year 1990 to all the way to 1999. That's one. Another thing we need to understand is that we are working with movie, not TV show. So there are movies, there are TV shows. So we're actually working with movies, only movie, not what? Not TV shows. So movies that are released in the year 1990 all the way to 1999. So yeah, it may not be easy to filter it. Like I have to be selecting from 1990, 1991, 1992 all the way to 1999. So, but with Python, with few line of code, we could achieve all of this in a jiffy. So the first thing we need to do, let's filter the data for movies released in the 1990. So I'm going to add a new line of code here and say filter the data frame. Okay, let's input a comment there. So I want to filter the data frame. So this Netflix data frame, I want to filter the Netflix data frame to show only movies. To show only movies, we want to only type movies, only type that's equal to movies and movies released in the 90s. In the 90s, let's say in the 90s. So in the 90s. So this is what we want to do. So we are going to be using, so we're going to save that as a variable. Say movies, and we just name it 90 movie. We say 90. Let's say movies in the 90s. In 90s. Okay, I think this is better. I'm not actually writing an English word, so it should be better like this. So movies in the 90s, you could just say Netflix. So we want to be filtering the data set. I could just say Netflix data frame. Oh, it's trying to save, and I'm running into a couple of errors there. I don't know, I'm running into a couple of errors there. Hold on a minute. I think it has saved successfully now. Let's see. So it's trying to save and running into a couple of errors. Hold up a little bit here. Seems it is my network that is acting up. Okay, I think we are back. Okay, let's see. You can say, okay, movies, and I want to filter these two data sets to only show us type movie and release year should be between 1990 and 1999. So let's see how we could do that. So movies in the 90 is going to be, so I'm going to use the curly brackets. It's simple technique. So you're going to be Netflix DF. So the saving is going to be causing a little bit of problem here. Oh, come on. I should just write, I think I should write this bunch of line of code in my Jupyter Notebook environment first before pasting it in this part of the code here, because it just keeps saving over and over again and causing trouble. Okay, so let me do this first in my local machine here. So it's going to be movies in the 90s. So we want to focus on the type data movie, not TV show, is going to be equals to it's going to be type. So I'm going to refer to the type column right here. So type column equals to movie. So I need the semicolon there, apostrophe. Type column equals to movie. I'm going to close the bracket there. So we're saying you should filter, we want to filter to only show movies that are the type, the Netflix movies or the Netflix record that are movie. And I'm going to use the and ampersand sign there. And let me just tap this. Netflix data frame where the release here, our release here column, which is this column here. Let's see if we can move forward. So the release here, right here, release underscore here is greater than or equal to 90, 90. Let me just give it a little bit of space here. So it is quite easy to read. 1990 and so it is between 1990 and 1999 and Netflix. Oh, there's an error spelling here. I'm not going to copy this. So on the release here, I'll just copy it again. Control C here and paste. Release here is less than or equal to. So it's going to be less than equal to 1999. Then we could just close the brackets like this. Let's see if you're not missing any error here. Let's run the code first. If you want it an error, you can clean it. Boom. Okay, you can see there's an error somewhere. So I didn't put all this in quotes. My column reference are not in quotes. You can see my error there. Voila. Now let's run the code again. Okay, I'm still missing something. Okay. So I'm missing my brackets here. I'm missing a bracket here. I'm missing a bracket here. I'm missing a bracket here. Let's run the code again. Netflix underscore data frame. The Netflix, come on. So my mistake was here. It's supposed to be outside there. Aha. Voila. So we've run. So you have to be pretty careful here while trying to filter the data set. Like I said, filter the Netflix data frame for type of movie that are just movie and release year is between 1990 and 1999. So it's going to filter these all rows of data, even though I'm supposed to run a couple of code before. Okay, let's see. Let me run this code here. Let me just add a cell above here. So you could see the whole number of rows that we have in the data sets. If I remove the header here, if I run the code, you can see that we have over 4,000 rows of data here. And in this case, we're only showing the first 5 rows. So I want to filter these all 4,000 rows of data to only a certain record. So since I've written this code, if I run the code and I come back here and say movies, I just say movies in the 90s. Movies in the 90s. If I run the code, I should just have, because I just have just over 100 rows of data. So the total movies released in between 1990 and 1999 is just 100 movies. Do you see it now? If you see the release year, you can see the release year 1997, 1993, 1998. Then we have also here the type is just movie, 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 movie. So to just make it easier, I'll just say it should show me the first 5 rows only. Dot add, just to make the code you can see there. So that's how we just filtered this whole large over 4,000 rows of data to only show us over 100 rows of data based on our filtering clause here. So I think we've answered the first question. I'll just same way copy this line of code and paste it in this my environment in the DataCamp. This is where we are submitting our answer. So I'll just paste it here. I'll just paste it there. Let's run this line of code and see. No error. Voila. So no error. I'll just copy this last part here and just make use of it in the same cell just to make it easier. If I run it now, it should show me that record. Let's see. You see, so we got same results as we did earlier here. We got same results here. So I think we just answered the first question. We should filter the data for movies released in the 1990s. Let's see how to do that, how to subset. So we use subsetting. So this is how we subset the data, these whole data sets. So by mentioning, by using curly bracket, square brackets to filter the data sets. So we use what is called subsets in Python here. We've learned all about that from the beginning of the lesson. So we've answered question number 1. Absolutely correct, you see. Let's move to question number 2. It says we should filter, as you can see, find the most frequent movie. It says find the most frequent movie duration. So visualize the data to view the distribution of durations for movie released in the 1990s. So we're going to be making use of these movies in 1990 to visualize our data set. So how do we do that? So since we filter the data set, it says visualize the data to view the distribution of duration for movies released in the 1990s. So we need to filter the data set. So we've done that from the beginning, from the first question. We're going to be making use of these movies in the 90s for data visualization in Python. So let's see how we could do that. Let's add a new line of code. So I'll write all this code in Jupyter Notebook first, then I'll paste it in the Python environment here. So we're going to call it and say, so let's see that. So we're going to say plot the distribution of movies released in 1990s. It says plot the distribution of movies released in the 90s or in the 1990s. I see the same thing in the 1990s. So we want to visualize this data set, these movies in the 1990s. I want to see it in a data visualization. And since we are asked to plot the distribution or the frequency of movies released in the 1990s, the duration, they mentioned the duration. Hold up a minute. They said visualize the data view. Visualize the data to view the distribution of durations. The distribution of durations. So we need to go to the duration column. This is it here. So duration of the movies. So we want to see the movies released in the 1990. Is it 30 minutes movie, 45 minutes movies, 90 minutes, 1 hour, above an hour. I want to see those movies released in the 1990. What is how many were released in for 30 minutes, 45 minutes, 1 hour, 82 minutes, and so on. Okay. It said plot the distribution of movies duration. So movies duration released in the 1990s. So that is question we need to answer. We're going to be using histogram to do this. So you want to see the distribution of, so it is best to use an histogram for this. So I'm going to say plot plt, so plt dot figure. So open and close brackets. Let's see. So we want to bring in the figure size. So we're going to customize the size of our plots. It's going to be figure size. Figure size, we can just make equals to 10. Let's have 10 bars by 6. So we want to create a plot here. And we're going to customize the size of the plot. So the next one is the so this line of code is just going to create a plot with customized size. This is creating a plot with custom size. So I want to plot an histogram now. Plot dot histogram. So I want to point it to movies in the 90s. I want to point these movies in the 90s. So our histogram is going to be plotting these movies in the 90s. And the column is to be plotting is the duration column. I want to mention the duration column. So the number of bins. So we need to put this in quotes, so it knows it's a column. So once we want number of bins for the histogram should be 20. Our color can be, let's give it a color, because just leave the default color there. Color can be, let's give it a red color. Then the edge color, we could give also the edge of the bins. Edge color should be black. Let's make it black. So, and let's close up the whole brackets. So we are saying you should plot an histogram of this movies data, this 1990 movies data, but you should plot only the duration column with 20 bins. Color of the bin should be red, then the edge color should be black. So next is we're going to mention the title, the title of the graph. The title is going to be distribution of movie duration in the 1990s. Let's get distribution of movie duration if we say released in the we could just say in the 1990s. So my mistake, I need to put it in quotes. So the next is we need to have the labels, the X and Y label. So our X label is going to be, so the plt dot X label. The label is going to open and close brackets. is going to be duration. So our x label is going to be duration in minutes, which is the x-axis. Duration. Our duration is in minutes. Minutes. Then our y label, plc dot y label, open brackets, is going to be frequency, the frequency of the movie. So number of movies released. So it's going to be frequency. Then finally, we just call on plt.show. So let's visualize and see what we've done so far, if it makes sense. Oh, we have an error there. Okay, it is seeing double quotes. So I can't just use it like that. Let's run it again. My plt.show is supposed to be double bracket here. Ooh, was never closed. Okay, I'm missing an error somewhere there. Figure size. Okay. Okay, there's seen an error there. Oh, I didn't close it. Okay. I didn't close. I have double quote there. Aha. You can see. So this is all we've done so far. You see the duration of movies that are movies in 25 minutes. They didn't release any movies under 25 minutes. The minimum here is above 25 minutes, probably close to 30 minutes here. And there are less movies there. But the highest movie is released in the 100 minutes. That is over an hour. So within those time. Interesting. So let's copy this line of code and paste it in our Python environment here. Let's see. Let's paste it here. I think we've answered the second question, but we still have one more question to answer here. Let's see. Voila. You can see. So these are the duration of movies released in the 1990. Distribution of movie duration in the 1990. Let's put movie durations in the 1990. So movie duration in 1990. So it's quite straightforward there. You could see the minutes and the number of movies released within those minutes. So I think we have one more question to answer here, which states that it says, what was the most frequent movie duration in the 1990s? Save an approximate answer as an integer called duration. Use 1990 as a decade start. So we need to know the most frequent movie duration. Most frequent movie duration. That should be within the 90, within the 100 minutes, if I'm not mistaken, or 97 minutes. Most frequent movie duration. When looking at the charts here, you can see it, but we should be able to use so most frequent movie duration. So what was the most frequent movie duration in the 1990s? So what we could do is most frequent. So once you see the most occurring number in the 1990, most occurring duration in this column, if we just use mod, the mode or mode number, so that is the most frequent number. That's what we want to look for, the most frequent movie duration. So we just use the mode figure there. So it's going to be duration. So I think we are told to save it because it's a save an approximate answer as an integer called duration. So I'm going to save it in an integer in a variable called duration. It's going to be duration equals to movies in the 90s. So let me just copy this filter data frame here. Movies in the 90s. So in the 90s, but we want to look at the duration column. The duration column here, I want to focus on the duration column here. Quote, duration column dot mode, as the highest occurring number there. Open and close the brackets. Then we just use subset to only focus on that column. So I'm just focusing on what? On this duration column with this 0 subset here. So we're going to, if I run the code now, it should go successfully, but we're going to display the result of the duration using the print function. I'll just say, okay. I'll just say print the most movie duration. We're going to print the most movie duration. I say the most frequent. I say the most frequent movie duration in the 90s, in the 1990s is approximately, then I'm going to use curly bracket this time around to point to the duration data frame there that we have there. This is our duration variable that we have here. I'm going to say minutes, and just close the bracket. Let's see if it's going to run successfully. You can see. Oh, I'm going to use a function. It's pointing to the duration here. I'm going to use a function here, the f function here. So it's going to filter out from this our column here. This is our duration column here to show that the most frequent movie duration is 94 minutes. Interesting. So you can see. So that's how we were able to get the most frequent movie duration. I'll just copy this line of code also and paste it in this place here to see if we are correct. Voila. So the most frequent movie duration in the 1990s is approximately 94 minutes based on the words our filtered data set here. So I think we've solved the question number 2. So let's solve the last question, which is this count. So it says count the number of short action movies from the 1990s. So we want to look at these are our movies that we filtered. The movie, we have them already. But the genre should be what? Action movies, not drama, not any other type of movie, but focus on action movies. So we're going to be writing this filter function again. We'll be adding another column, which is genre to it. Then the genre should be action movies. So let's see it in action. Let's see it in action. So I'll just copy this line of code again, but let me just go back to my Jupyter notebook here and copy it all the way from here. Let's see, where is that line of code? Right here. Let's copy this. So to save time, so I may have to be writing all the whole bunch of code from scratch again. So now I want to what? I want to filter to only show movies that are action movies. Filter the data for 1990s action movies. So filter net data thing to show only type movies and movies released in the 1990s and action. and genre, and the genre, I hope I'm pronouncing that correctly. The genre is action movies. So I just add an and function to this and say, and the Netflix data here. I just copy this line of code all the way from here. Control C. Instead of release here, I'm going to be pointing to the general column. I hope I'm pronouncing that correctly. General column here. This journal, Genre. We want the journal should be action. So we're going to do a little trick here. So we want it to be string dot string dot contains open brackets. Then I'm going to mention the action here. I didn't just want to point to action, because if I just say general equals to action, so there could be some action that are spelled from capital letters, capital small letter A C T I O N, while some will be A C capital letter A C T I O N. So I'm trying to make room for, no matter how the letters in the actions are spelled, is going to see them as action movies. You get it now? I hope that makes sense. I could have just easily point to general equals to action without using this string contains actions. Then the case, I'm going to say case of that case equals to false. No matter the case in which the action is written, it's going to see the results. Just close the bracket one more time and we wrap it up with this. Let's run the code. Oh no, we need to make sure action movies. Let me just add action movies here. This data frame should now be, this variable should be action movies in 90s. Voila. Oh, I'm going into an error. Case equals to false. Probably because I'm writing a capital small letter there. Voila, I guess that's voila, you see. So if I call on the action movies in the 90s, it should only return action movies. We filter the data set again. One more time. Let's run the code. Ooh. Let me put, actually I need to put this data frame object is not callable. Why is it not callable? We should be able to call it. Interesting. I think we should be able to call, this is invalid, I guess so. But the bunch of code here is correct. It's correct. But I was hoping we should be able to call it, even though we are filtering same data set over and over again. We should be able to call it though. This is not fair. But let's work with that. Okay, let me just copy this line of code here. Also, mm, let's write one more line of code here and see it in action also. Oh, successful. But we should be able to call it. So if we've filtered, okay, count the number of movies, action movies from the 1990s. So we filtered to only show us action movies in the 1990s, but we should be able to, now let's count it. Now the issue now is now counting it. Okay, it says a movie. Now there's a clause here also. So a movie is considered short if it is less than 90 minutes. So count the number of short action movies released in the 1990s and save the integer as short movie count. So we need to save it as short movie counts. So now we filtered to only show action movies in the 1990s. And we need to add another filter, the duration also to it. This is not fair. Now let's see it in action. Let's see. And let's finally count now. We've actually filtered the Netflix data frame to show only type movies and movies released in the 1990s, and the genre is action. And let's see it one. Now let's now count it now. Now counting, okay, we can just say count. Now I want to count these movies. Count the number of shots, action, movies less than 90 minutes. 90 minutes. Now we need to count it. So we need to save it in a variable called, they say short movie counts. So short underscore movie underscore count is now going to be equals to action movies in the 90s. I'm going to call on our variable here. Action movies in the 90s. Open square brackets. The action movies in the 90s one more time. I'm going to point to the duration column this time around. Duration column. Duration column less than, I'm going to say duration column is less than 90 dot shape. So I'm going to say dot shape just to show the shape of those records. Dot shape. So it's going to focus on the duration column. 5 points. If I use the subset 0 on it, so let's run the code and see. You can see it runs successfully. So I just filtered this whole record here, this action movie in the 90s. So look at the duration column and only counts the number of movies that are that have duration less than 90 minutes in the column. So to print it now, I'm just going to use the same method, this print method here also to display it. We're going to be print the number of short action movies. Going to be short movie count here. So I'm going to point to this short movie count here. We spend 1 hour on this project. Going to see short movie counts. So I'm going to clean this whole string here. Say the number of shots action movies less than 90 minutes released in the 1990s in the 1990s is, so it's going to look at this short action movie count and just show us the result there. You can see 0. Oh, that should be wrong. That is wrong. That is wrong. There's a mistake somewhere. Less than 90. Let's see it on this on DataCamp platform here. Let's run the code and see. Is not returning any results. Why? Okay, still saving. saving field. It's only zero. The number of short action movies less than 90 minutes released in the 1990s is not zero. It can't be zero. Something is wrong in this last line of code. We've actually filtered the data frame to this. Hmm. Looking at probably something is wrong here with this our case actions. Hmm. Oh, let's look at the spelling of the action here. Action. It's just action, not actions. Okay. Where did I put it? I put actions. Oh, my mistake was using actions rather than action. We see. You see my mistake there? Let's run the line of code again. Okay, so my mistake was I spelled action wrongly. Well, I can see now. So you have to be pretty careful when trying to run your bunch of code. Instead of action, I wrote actions. Interesting. Can you see now? Voila. So you have to be very, very careful while trying to write this line of codes. And if we just misspell anything simple and it is totally wrong in already. Voila. So let's submit. Let's hit submit here and see if we nailed it. If you got all the bunch of codes correctly, let's submit. Check in. Voila. Woo, we nailed it. So that's just a simple, and this is like a guided project. You can see the questions are being provided for us. We only need to bring out a bunch of code and try to solve the whole challenge ourselves. So that's interesting to see. So if you want me to release this line of code, you definitely have it. If you watch this live stream, you could just follow along, pause the video, and try to write the code yourself from scratch. And try to understand what each line of code is doing. And if you get confused, I encourage you to go and watch this live stream, this learning journey live stream, all the way from day one, which is from the Python basics, where we actually learned all about all this basic Python line of code we actually use to visualize the data, to ask counts and use and function. You get it now? Learning to subset and call on certain columns for your analysis. So that's all we've done so far in this learning journey. So on the next live stream, which is tomorrow, which is day 19, we're going to continue our learning journey. Probably try to keep practicing with this, what we've learned so far. So good. If you find value in this learning journey with me, do well to subscribe to the channel by giving the video a thumbs up so you can always be the first to know whenever I go live or drop a new content on the channel or start working on a new project in Python. As usual, I will see you in the next video. Go watch the next video on the channel and do make sure to start from day one so you understand all this bunch of code that I've written so far in this investigating Netflix movie project. If you enjoyed this project, do well to give this video a thumbs up and I'll see you. Do well to share your data project with me in the comment section and I'll see you in the next live stream on day 19 as we continue our learning journey on 100 days of Python. Do have a wonderful day. Bye.